The LIBPF Model Wizard is a web application, so let's open the browser. I paste in the URL to the LIBPF Model Wizard. As it is a large web app, it can take 5 to 20 seconds to load from the LIBPF.com website. But as it is open source, you can also run it locally. In this case, that would be faster. The wizard is initially empty. The easiest way to fill it is by loading one of the samples. I select the salt pepper sample, and the model form gets populated. We can see this model has no integer options, no string options, and no variables. But of course, it has unit operations. We can zoom into the SPL unit. Each unit has a name, description, and type. This one even has a one integer option. The salt pepper model also has streams to connect the units. Let's zoom in to the S6 stream. The stream input form is richer because besides name, description, and type, you also need to specify the source and destination units and ports. The units and streams define the connectivity. The wizard offers you a graphical preview of this connectivity as a process flow diagram. It also generates the C++ code, the interface, the implementation. Notice that if I click twice on the File tab, the code gets selected so that it's easier to copy into the clipboard. And finally, it generates the driver too. Let's try something more interesting now. Let's modify one of the examples. First, we clear the form. Then we load the microturbine example. Let's look at the process flow diagram as it stands now. Currently, the only stream that goes to sync is S07. Let's go back to the model and look at S07. It is the recuperator exhaust. Suppose we want to feed the recuperator exhaust into a postcombustor. Let's add the new post unit first. We set the type to Other because we'll use a custom model for this one. If you look at the process flow diagram, now the post unit is floating and unconnected. We must connect the S07 recuperator exhaust stream to the post. Now, if we look at the process flow diagram, it's the sink that is unconnected. We must then add a new stream, S08, to bring the post exhaust back to the sink and out of the flowsheet. The type of new stream will be stream vapor because we expect it to be vapor only. Finally, the process flow diagram is correct. In the implementation, we can find the C++ code that's been added to create the post unit and connect it. If you would like to learn more, click on the Info tab and read the documentation. And happy process modeling!